In lesson 6 here, we're going to talk about forming and naming molecular compounds. Molecular compounds, of course, are nonmetals and nonmetals now, so we're focusing on the right-hand side. Molecular compounds are composed of nonmetal atoms. In molecules, the atoms are joined together by what we call a covalent bond. So the electrons are no longer transferred, they are sharing electrons. And there's a reason this happens. We're not going to get into it this year, but we will talk about that eventually. And then they give you the example of hydrogen there for, for example there. So what happens is, okay, hydrogen has basically this one electron that's going around the outside here, yes? And what happens is these two nucleuses, okay, so we have the one proton and the one electron, yes? This one electron here and the proton here is here, the nucleus, right? And here's the nucleus here. And this one has its one electron. And what happens is those two hydrogens will get very close to each other, and they will basically help each other out to become more stable. Because of course, hydrogen is number one. If it could become more like helium, that would be great, all right? It'd become more stable. It have two electrons in the outside energy level. So how it does that, it kind of cheats a little bit, and there's no give and take because they're both hydrogen atoms. They both want to share these electrons. They're both nonmetals technically, okay? So this electron here and this electron here. So what they'll start to do is instead of just doing this, they'll start to go around both like this, all right? And so those two hydrogens will get very close together, and then those two electrons will start to go around both of them, okay? And it kind of pretends, so this hydrogen kind of has two electrons that go around it, and this hydrogen has those same two electrons that go around it, okay? So they're kind of helping each other out a little bit. All right, that's exactly what's happening with the oxygen in the air right now. So oxygen usually comes in twos, yes? Because again, there's 6 valence electrons, yes? 6 in the outside energy level, right? So 2 in the first, 1, 2, 3, 4, 5, 6, 7, 8, yes? So 6 in the second one. And it's short 2, but along comes another oxygen, and those ones that are by themselves pair up and basically kind of complete that octet. Okay, so they share. That's why oxygen comes in twos. Nitrogen comes in twos. Fluorine comes in twos. Chlorine comes in twos, et cetera, et cetera. All right. So it says here in a molecule, the electrons are not transferred between atoms like they are for ionic compounds. How might two fluorine atoms achieve a filled valence energy level? Again, look, there's one by itself here, and there's one by itself here. If we kind of paired those up, paired them up, okay, so that this one kind of spends some time here, and then these two kind of spend time here, okay, it's like we have 8 in each one. Basically, that's what's happening, okay. It's a little easier to show that with hydrogens, but we can do that with fluorines as well. So again, I'm just going to do the outside energy level, if that's okay, because you guys don't know Lewis diagrams yet, but in the outside energy level, we'd have 1, 2, 3, 4, 5, I'm going to skip that one if that's 6, 7, okay? So they kind of have these 7 going around the outside energy level, yes? 2 in the first, which I didn't write, and then these 7. And then along comes another fluorine atom, of course. They're gases, so they're probably in the air and et cetera, et cetera. And here comes another one, and again, we have 1, 2, 3, 4, 5, 6. And I'm going to put that one right there. And basically, those are the ones that are going to get shared, okay? Each fluorine wants to have 8 around it. So basically, this one kind of has those 8 right there, and then this one kind of has those 8 there, okay? And technically, they probably, around these two, again, would probably do this kind of thing all together, kind of thing, okay? So they both have 8, kind of, all right? And that's how they share them. Now, this can happen between same elements, like FF, or HH, or NN, or OO, and I'm not sure how far I should jump ahead here, but we call those, I think they're going to be molecular elements, okay? So we call those the molecular elements, and we'll get to that in a second here, all right? So it happens between same elements, but it also happens, like I said, you already have this diagram there, but it happens between similar elements like HH, NN, OO, okay, we call those molecular elements. It happens between different elements as well, like hydrogen and chlorine, for example, will do the same thing. They'll share electrons. Okay, it says here we're going to do this, but just for time's sake here, I'm going to show you how hydrogen and oxygens combine together to share electrons, all right? So in this case here, we're going to talk a little bit about water. So water looks a little something like this. It's got you can write this down. This is the challenge here part. 8 protons, 8 neutrons. We got two electrons in the first energy level, and then 1, 2, 3, 4, 5, 6 in the next energy level. 2 and then 6, yes? Let me just, oopsies. Okay, I'm just gonna move this over. Oh. There we go. Okay, so 8 protons, 8 neutrons for a total of 16, yes? And then 8 electrons, so 6. Along comes a hydrogen. I'll do that maybe in a different color here. H has got a 1 plus here, that's the nucleus, and then it's got this 1 electron here, okay? And again, what's going to happen is that hydrogen is going to share its electron with the O. So these two are going to kind of pair up here. Don't do this part, but those two are going to kind of pair up to make 2 there, yes? So basically, if you look at it right now, and like I said, don't draw that little circle there, but this hydrogen has 2, right? It's more stable, correct? Hydrogen's got 1 electron, but now it's kind of pretending like it's got 2, yes? Because it's now more like helium, right? Okay. This oxygen now has 2, 4, 5, 6, or sorry, 2, 4, yeah, 5, 6 there, right? And then technically there's a 7th one there, okay? And again, this is how water is formed. We have this bond here. Again, don't draw that circle there. In fact, I'm gonna try and get rid of that right there, right there. And then down here, we're gonna have another hydrogen, 1 proton, there's the nucleus, and there's the 1 electron. And again, it would share those 2 electrons, okay? So when we look at this, okay, and there's a reason that they share, and again, we're gonna have to be a little patient. For right now, what do we tell you? How do you know that they share? What kind of compound is this? It's what? Molecular. It's a molecular compound. How do you know it's a molecular compound? Yep, 2 nonmetals, okay? So that's what you know for now, and that's good enough, okay? Basically what happens is, in this case, that's our definition of what a molecular compound is, and that's why they share, okay? They're 2 nonmetals, so we're gonna say, hey, these share electrons, and that's what we're gonna go with, okay? So 2 nonmetals, of course, on the right-hand side. Hydrogen's considered to be a nonmetal as well. It's kind of unique, actually. Hydrogen's actually unique. Can act like an ionic compound at times, too. It depends on what you kind of pair it with. And then, again, here and here, okay? So this hydrogen, if you look at this hydrogen, it's got 2 electrons. If you look at this hydrogen, it's got 2, yes? And then you look at the oxygen, okay, and it's got, if you look at all those, 8 in the outside energy level, yes? Okay, so 2, 4, 6, 8, yes? Okay, and that's basically what happens. Again, these nucleuses would get really close together. It probably doesn't look exactly like this. Water does have this kind of shape to it, but their electrons would be probably going around everything here, okay? Yep. No, no, okay? In a covalent bond, electrons are shared between atoms so that the octet rule can be satisfied. Remember, with molecular compounds, sharing is caring, which I think you have there, caring, sharing, or whatever. All right, naming, binary. We only do binary molecular compounds for now. Later on down the road, maybe you'll do more, but that's different kind of, we do organic chemistry then, and that's a whole other issue there. So for now, we only do 2 nonmetals, all right? We write the name of the first nonmetal, so whatever it is. So for example, if it was sulfur or nitrogen or whatever the case might be, write the name of the second nonmetal, and we do need to change it to an I, okay? So for example, if it was sulfur, it becomes sulfide, kind of like naming ionic ones, right? Chlorine, chloride, et cetera, et cetera. We add a Greek prefix to the first nonmetal if there is more than 1 atom. So for example, we'll get into some examples here, and I think we'll just wait for that. And we always put a prefix on the second one, okay? Basically, the only time you don't need a prefix is if the first element is only just one, okay? So like just carbon or just nitrogen. If there's two nitrogens, we need a prefix for that. We'll get into some examples here, okay? The Greek prefixes are, right, do I have those? No? They're not, I don't have those. Well, here you go. They are mono, I thought I did. Sometimes things go missing on me here. Mono, di, tri, those are the first three. Tetra, penta, that is the first five there. Okay, I'll go over here. Hexa, hepta, octa, nona, and deca. Okay, those are your first 10 there. All right. Okay, we're going to do these examples here, and then we're going to move on. Okay, so you have these at the bottom of your page there, the examples, bottom of the first page. CS2, so again, okay, only one carbon, so we don't need a prefix with the first one. So this would be carbon. Okay, we always need a prefix for the second one, no matter what. So this is CS2, of course. We need 2, which is di. Sulfur becomes sulfide, yes? So this is carbon disulfide. Okay, we're always going to change the ending to "ide." All right? Like I said, we don't need a prefix with the first one because there's only one. Okay? This one here, so this is N2O4, of course, which you can see right beside it there. Now, this one has 2 for nitrogen. We do need a prefix, right? So we need di-nitrogen. Sounds kind of mean. Di-nitrogen, okay? And then we need to have 4 oxygens. So 4 is tetra, and then oxide. Okay, sometimes you'll see no A there, that's okay as well, but usually, well, it depends kind of, but I usually just leave the A there, tetraoxide, okay? So like I said, if we have 2 or more for the first one, we need a prefix, and we always use prefixes for the second one and the ide. There's no swap and drop here. All you have to do is tell me how many of each atom you have, right? So dinitrogen, 2 nitrogens, 4 oxygens, tetraoxide, okay? All right, flip it over. If we're going to write the formulas, again, we have to kind of just look at the name, decide on how many of each one we need. Okay, I think for the most part, there's no swap and drop or anything. Sulfur dioxide, so this means we have 1 sulfur because there's no prefix with it. Sulfur, and then di, so that's a 2. Oxide, because of course oxygen with a 2 behind it, yes? Sulfur dioxide. This one here does have a prefix and nitrogen, so nitrogen, dinitrogen, looks like that. Dinitrogen, okay, sounds mean again. And then here comes the money, trioxide. You'll like it. Trioxide, you'll like it. Oxygen. Okay, and like I said, there's no swap and drop. We just literally write down tris, 3, oxide, O. Okay, so basically like that. Okay, real quick here, I think we have some time for this. Molecular elements. So here's more fun for us. So some elements exist as molecules. So when you're walking down the street, for example, you know, when we look at oxygen in the air, oxygen's going to come in 2s. Again, to help each other become more stable, okay? This one has 6. It's got 2 by itself. This one has 2 by itself, and they're like, hey, let's share those between us, okay? And then we're going to fulfill our octet rule, basically, or fulfill those 8. So they become a little more stable, okay? So some of these nonmetals will come as something called molecular elements, okay? Make sure you know this term. Now, they say diatomic, and you may have heard, I don't know, do you know this? Okay, we don't really use diatomic anymore because there's other ones as well. So I just call them molecular elements, okay? That's the key here, molecular elements. Now, there's a couple ways to remember these. I don't know, did you take these in grade 9? I don't remember. Yeah, no, maybe you forgot, I don't know. So the one way to remember these is it's something called Hofbrinkel. So hydrogen is 2, oxygen is 2, F is 2, Br 2, I 2, N 2, Cl 2. Okay. There's other molecular elements as well, which most of the common ones would be P4. So phosphorus usually comes in 4s, and sulfur usually comes in 8s. Okay. Ozone is not that common, so we usually don't. Just be aware that that is technically a molecular element. The term molecular element comes from the fact that they're elements that are joined together to form a molecule. In other words, a couple of them come together and they've bonded together, or shared together, covalently bonded together. Okay. Have we talked about covalent? Covalent, yeah. Yeah, I forget already. Yeah. Yeah. That's a molecular compound because it's different elements that have combined together. Yeah, it has to be 2 of the same thing. Okay. Or in some cases 4 of the same thing, or 8 of the same thing, or 3. Right. And there's other molecular elements as well, but these are kind of the common ones that we do. Okay. So Hofbrinkel is one way to remember that. That's right here, Hofbrinkel. Okay. The other option is I have one that I do like this. And I don't know why, but this is the one that I was taught a long time ago. I remember this from like, I don't know, a long time ago, like way before. I have this, and then I have a little thingamajigger that I say with this acronym or something like that, I think, or when you match up letters to words or something. I don't know. I don't teach English well at all. Good, know how. But I have, I don't know what it's called, you know. I have, and this might be true for some of you, no, bright, or clever friends, right? Everyone's looking around at their friends right now. Okay. Huh, how about that? He knows. And then I had to finish it off with something, so I said, so I was told people stupid. Okay. I have no brighter, clever friends, people stupid. That's how I remember them. I remember that from like literally grade 8 because it's catchy and true sometimes. You know, so whatever you want to do to remember those is probably, like I said, there's Hofbrinkel. That's the one that most people use nowadays. This is old school. That's like, I don't know, 2 years ago or so, grade 9. That wouldn't make sense. Wait a minute. Anyway, the math's complicated. I'm not going to get into it. But I remember that from a long time ago. So whatever you want to do, I don't care. But these are kind of the most common ones: is I2, H2, N2, N2, Br2, O2, Cl2, Pf2, P4, and S8. Those are the most common ones. O3, we talk about ozone. We'll talk about it later, but it's not really one that we use a lot. You know, if we're combining elements together, usually it's not O3, it's oxygen, O2. Okay, O3 takes some special energy to do that. That's why it's way up in the atmosphere, right? Ozone. Okay. What's next? And lastly here, I guess. So yeah, naming ionic versus molecular, of course. If you have to decide which one are you doing, ionic or molecular, what are you going to look at first? How do you decide if it's going to be an ionic compound or molecular compound? Yeah. Yeah. Metal. Right. So you're going to look at basically what are the elements, right? If a metal comes first, it has to be ionic, yes? If a non-metal comes first, it has to be molecular, right? So the first element will tell you basically which one's going to be which, yes? There's another way, of course, and we could look at naming, right? So if there's prefixes that are included, if you have prefixes, that means it's going to be molecular, right? Because we have to describe how many of each type of atom we have. If there's no prefixes, then it's ionic because there's only one way they can combine, right? Excuse me. All right. So ionic compounds will be made up of a metal and a nonmetal, or they might contain a polyatomic ion as well, of course. So instead of sodium chloride, for example, Na and Cl, it might be Na and nitrate, for example, NO3, right? So the most important thing is the metal comes first. Or I guess the other option is if this comes first, right? Because that's technically your metal there, yes? Ammonium, that's the one exception, I would say, yeah? So that's another option there. So a metal comes first, or that, if you see that first, that'll be a good clue here. Molecular compounds will only contain non-metal atoms. And another way to easily tell is this. Look, we only know how to name 2 non-metals, yes? Like, you're not going to get something like this. 3 non-metals, right? Because you don't know how to name that, correct? How would you name it? You can't, right? So you're not going to get that, 3 non-metals. The most you're going to get is like, you know, CO, carbon monoxide, for example, right? Or carbon dioxide. So you're only going to get 2 non-metals, of course. So that's another kind of way you can tell. If you got a whole bunch of stuff, like if you got NH, you might be like, well, yeah, but NH4, right? Those are non-metals, yes. But then you put this on, well, that's another non-metal now. How would you name that if we're going to do that molecular compound-wise? There's too many letters there, right? So obviously what's happening here is this is the 1 plus, and that's the 2 minus, right? Ionically, polyatomic ions, yes? Okay, does that make sense? Yeah. No. 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 Okay. Good. Any questions? Okay, we're going to give these at the bottom here a try. So this is molecular. Tomorrow, I'm going to give you basically this. Tomorrow, I'm going to give you a sheet that's kind of like a little review of everything. Okay. Yeah, we'll see about time here, but I'll give you a sheet that has ionic and molecular, and we'll kind of do that tomorrow. We'll go over this tomorrow. Make sure all these questions are done for tomorrow, in case there's any confusion about that. So 1 through 3 and 4 for tomorrow, okay? And then, like I said, I'll give you back hopefully I'll give you back your quiz tomorrow.